Hello students, welcome to AIMS India's online classes in this chemistry session. In this, we are going to discuss about atomic structure chapter, particularly about quantum numbers. As we know, to search a particular person in this world, four things are needed. The country to which the person belongs, the city in that country to which the person belongs, the street in that city where the person is residing, and the house number. If we know these four, we can locate or we can search a particular person in this world. If you know the country in which belongs, and the city in that country, and the street in that city, and the house number. If you know this, we can reach that person. Similarly, four identification numbers are required to locate a particular electron in an atom. These set of identification numbers are called quantum numbers of that electron. Okay, the numbers which are used to locate or to identify an electron in a particular atom are called as quantum numbers. So four numbers are used for location of an electron in the atom. Those four numbers together called as quantum numbers. So out of those, the first one is a principal quantum number. It was proposed by scientist Niels Bohr, and this quantum number is denoted with the symbol n. Principal quantum number is denoted with the symbol n. It represents the size, name, and energy of the shell to which electron belongs. So, if we know the quantum number, principal quantum number n value, we can say in which orbit electron is located, and the size of that orbit, and the energy associated with that orbit. These all can be known by knowing the principal quantum number value. See here, principal quantum numbers values are given like this. If principal quantum number value is 1, that means electron is present in K shell. Name of the shell is K shell. It is present in the first shell. And we can say it is we can calculate the distance from the nucleus also. The size of the orbit also can be calculated if we know the value of n as 1, because we have formula to calculate the radius of the orbit. R is equal to, we have some formula there, right? By using that, we calculate radius. In the same way, we can calculate the energy associated with that value, or the electron's energy in that orbit also can be calculated by using the formula. So if we know the principal quantum number value, we can find the name, size, and energy of the shell to which that electron is belonging. Okay, the value of n lies between 1 to infinity. So there might be infinite number of orbits in an atom. So n value will be in between 0 to infinity. That means n is equal to 1, 2, 3, 4 and so on till infinity. It might be any of these. So this represents number of the orbit. The value of n is equal to, suppose if it is 1, that represents K shell. If the value of n represents 2, that is L. If it is 3, M shell. 4, N shell. In this way, the value of n represents different shells. So the designations of these shells are given as K, L, M, N and so on. Okay. Higher is the value of n, greater is the distance of the shell from the nucleus. Yes, as the n value increases, the distance from the nucleus also will be increasing. Yes, as the number of the shell increasing, its distance from the nucleus also increases. So as the greater is the magnitude of the energy of the electron also. Yes, as the distance from the nucleus increases, at the same time, energy also increases for the electron. If electron is very near to the nucleus, its energy will be less. As n number increasing, the orbit number increasing, the distance from the nucleus also increases. At the same time, energy of the electron in that orbit also increases. Energy separation between two shells decreases on moving away from the nucleus. Yes, the energy level difference between the two adjacent orbits will be greater near to the nucleus. As we move away from the nucleus, the energy difference between the adjacent orbits will be gradually decreases. That means the energy difference between the first two orbits is greater than the energy difference between the second and third orbits. This is greater than the energy difference between third and fourth orbits. In this way, the energy difference between the adjacent orbits gradually decreases as we move away from the nucleus. Maximum number of electrons in a shell is given by the formula 2n square, where n represents number of the orbit. Suppose if you want to calculate the maximum number of electrons that can be accommodated in the first orbit, if you keep in the place of n 1, we get the maximum number of electrons that can be accommodated in the first orbit. 2 into 1 square, that gives 2. Okay, if you want to calculate the number of electrons present in the fourth orbit, the maximum number of electrons present in the fourth orbit. So in the place of 4, if you in the place of n, if you substitute 4, we get the total number of electrons that can be maximum accommodated in the fourth orbit is given as 32. So the formula to calculate the maximum number of electrons that can be accommodated in a shell is 2n square. Second, next quantum number, Azimuthal quantum number. It was given by Sommerfeld. It is also called angular quantum number or secondary quantum number. It is denoted by L. Its values lie in between 0, 1 to till n minus 1. So its values are in between 0 to n minus 1, where n is principal quantum number or orbit number. Okay, its values will be in between 0 to n minus 1. It describes the shape and name of the subshell associated with the main shell. Yes, it gives the shape of the subshell in which the electron located in a particular orbit. Suppose if L value is equal to 0, that represents S subshell. If L value is equal to 1, that represents P subshell. If L value is 2, D subshell. If L is equal to 3, F. If L is equal to 4, G subshell. So in this way, L value represents the subshell in which electron is located. So by that we can say the shape of the subshell also in which electron is revolving around the nucleus. See here, the shapes are represented here. If the L value is 0, that represents S subshell. We know S subshells are in spherical shape. And if L is equal to 1, that represents P subshell. In P subshell, orbitals are in the dumbbell shape. If you see L is equal to 2, that represents D subshell. In the D subshell, orbitals are with a double dumbbelled shape. Whereas if you see L is equal to 3, that represents F subshell. In F subshell, orbitals are with a four-folded shape or complex shape. So in this way, the L value or Azimuthal quantum number value gives information about the shape of the orbital or the shape of the subshell in which electrons are located. The energies of the various subshells in the same shell are in the order of S is less than that of P is less than D, F, G and so on, increasing order. So the electrons in the S subshell are having lower energy and the electrons in the P subshells are greater and the D electrons are having much more energy. In this way, the energy increases in this order, S, P, D, F, G and so on. Okay, these are increasing order of the electrons in the different subshells in the same orbit. Maximum electrons that can be accommodated in a subshell is given by the formula 2 into 2L plus 1. So if you know the Azimuthal quantum number value, we can say the subshell. So in that subshell, how many electrons can be accommodated can be calculated by using the formula 2 into 2L plus 1. Suppose if you want to calculate the number of electrons that can be accommodated in the S subshell. S subshell means L value will be 0. So if you substitute L value 0 in this, we can get the maximum number of electrons that can be accommodated in the S subshell. What do we get if we substitute 0? 2 into 0, it becomes 0. So plus 1, totally 1 inside. 2 into 1, 2. So maximum 2 electrons can be accommodated in the S subshell. If you want to calculate the maximum number of electrons that can be accommodated in the P subshell, so if you substitute in the place of L, 1, because L represents 1, P subshell represents L value 1. So 2 into 2 into 1, 2, 2 plus 1, 3, 3 into 2 total becomes 6. So 6 electrons can be accommodated in the P subshell. So in this way, maximum number of electrons that can be accommodated in a subshell is given by the formula 2 into 2L plus 1. Yeah, it is given here all. S subshell can accommodate 2 electrons, P can 6, D can 10 electrons, F 14, G subshell can accommodate 18 electrons. Okay. S, P, D, F and G are actually these symbols are taken from here. S represents sharp, P represents principal, diffused, fundamental and generalized. So from these terms, these denotations are taken for these subshells. Next quantum number, magnetic quantum number. Third one, magnetic quantum number. It was proposed by scientist Lende and it is designated with the symbol M. It describes the orientation or distribution of electrons cloud around the nucleus. Yes, it gives about information about the orientation of the electron. Orientation means along which axis electrons are revolving around the nucleus. That was given by orientation, that is said to be orientation of the electron. This is given by magnetic quantum number value. For each value of L, the magnetic quantum number M may assume all integral values from minus L to plus L, including 0. So, if we know the L value, we can find M values. So, magnetic quantum number values will be varying from minus L to plus L, including 0. So, for a given L value, Azimuthal quantum number, total number of magnetic quantum number values will be given as 2L plus 1, because minus L to plus L including 0. Total becomes 2L plus 1 values will be getting. So total number of magnetic quantum number values for a Azimuthal quantum number value are 2 in 2L plus 1. Thus, suppose when L is equal to 0, suppose Azimuthal quantum number value L is equal to 0 is given, that means S subshell. Then magnetic quantum number value becomes 0, because M values are from minus L to plus L. L value itself it is 0 here. So M also will be 0, means only one value it is getting M here. Orientation is only one kind of orientation is possible with L is equal to 0. That means in S subshell only one kind of orientation is possible. Their orientations are also called as orbitals. So S subshell can have only one orbital. That means only one kind of orientation. If you say L is equal to 1, that means the P subshell. In that M values will be minus L plus L, minus 1 plus 1 including 0. That means M values will be minus L to plus L including 0, we are telling no. So M values will be minus 1 plus 1 and 0. 3 values it is getting. That means 3 types of orientations are possible in P subshell. That means there are 3 orbitals in L subshell. P subshell contains 3 orbitals, whereas S subshell has only one orbital. Yes, 3 kinds of orientations. One will be along x-axis, other one will be y according to y, and the third orbital will be according to z-axis. So 3 orientations are possible in the P subshell. Next, when L is equal to 2, means Azimuthal quantum number value L value 2, that represents D subshell. In that total M values will be minus 2 to plus 2 including 0, totally 5. Minus 2, minus 1, 0, plus 1, plus 2. Totally 5 values are possible. So we can understand there 5 orientations are possible. That we can say as 5 orbitals are present in the d subshell. These orientations are said to be orbitals. So there are 5 orbitals in d subshell, that is L is equal to 2. Next, if L is equal to 3, we can say minus 3 to plus 3, total 7 values, 7 orientations, that represents 7 orbitals in F subshell. Each orientation corresponds to one orbital. Okay. Thus, the number of m values indicates the number of orbitals in a subshell with a particular L value. Yes, the number of L value or azimuthal quantum number L value gives the number of subshells present in that, number of orbitals present in that subshell. The total number of orbitals present in each subshell is given by the formula 2L plus 1, which we said as the total number of orientations possible is 2L plus 1. These orientations are said to be here orbitals. Okay, orbitals means actually what is the definition? The places or the regions where there is a finite probability of finding electron around the nucleus are known as orbitals. The places or the regions where there is finite probability of finding electrons around the nucleus are said to be orbitals. See here some outlines or the shapes of the orbitals are given. S orbitals are in the spherical shape, p orbitals are in the dumbbell shape, d orbitals 5, they are in the double dumbbelled shape, f orbitals are in the four-folded shape or complex shape, that is called. As the number of the subshell increases, the complexity in the shape of the orbitals also increases. Okay, this is about the different shapes of orbitals. So s orbital shape is said to be spherical, and the shape of the p orbitals is said to be dumbbell shape. Shape of double dumbbelled shape. D orbitals is said to be double dumbbelled shape. Whereas the shape of f orbitals is said to be four-folded shape or complex shape. So as the number of the subshell increases, the complexity in the shape of orbitals that also increases. Okay. Next one, spin quantum number. The fourth quantum number is spin quantum number. It was given by the two scientists Uhlenbeck and Gaudsmit, and it is denoted with the symbol S. Spin quantum number represents the direction of electron spin around its own axis. Yes, electrons are just like the planets. They revolve around the nucleus and they have their own rotation also, self-rotation also. This spin quantum number explains the self-rotation of the electron, the self-rotation direction of the electron. So in this way, two types of self-rotations are possible. One is the clockwise spin, other one is anti-clockwise spin. For the clockwise spin, S value is given as plus half. That while denoting the diagrammatic representation, this is represented the upward arrow mark. For the anti-clockwise spin, S value, spin quantum number value is given as minus half. In the diagrams, it is represented as downward arrow mark. Okay, in this way, spin quantum number has two values, minus half, plus half. Means the two types of self spins are possible for electrons. One is the clockwise spin, other one is a anti-clockwise spin. If electron is having clockwise spin, it is given value S is equal to plus half. If electron is in the anti-clockwise spin, then S value is given as minus half. Now, this is about the spin quantum number. So in this way, we can say about four quantum numbers. Azimuthal quantum number. So these four quantum numbers gives exact address or exact location of an electron in the atom. First, shell number gives the number of the orbit in which electron is located. In that orbit, again, there will be different subshells. L value, azimuthal quantum number value gives in which subshell that electron is located. Suppose L value, N value, if we take it as L value, suppose if you take it as 3, that means electron is present in the third orbit. That we can understand. But in the third orbit again, there will be different subshells. There will be S subshell, P subshell, D subshell also will be there. So to know in which subshell electron is located, we have to know the second azimuthal quantum number value. Azimuthal quantum number value represents the subshell in which electron is located. Suppose L value is given as 1. That represents that electron is located in the third orbit in P subshell. L is equal to 1 represents P subshell. Okay, again, by coming to P subshell, 3 types of orientations are possible for the electron. One along x-axis, other along y-axis, and the third one along z-axis. 3 types of orientations are possible. Now, to know according to which axis electron is revolving around the nucleus in that particular subshell, we have to know the third quantum number, that is magnetic quantum number value. If we know magnetic quantum number value, then we can say the orientation of that electron also. So in the P, suppose if it is given M value plus 1, then we can say the electron in the third orbit in the P subshell. In the P subshell, it is having x-axis orientation. We can say suppose it is px orbital. Okay, so electron in the third orbit P subshell with px orientation. In that px orientation, nothing but px orbital. Again, 2 electrons can be presented. One with clockwise spin, other with the anti-clockwise spin. Which spin it is having? To know that, next spin quantum number should be known. If the spin quantum number value, if it is given as plus half, that represents electron in that px orbital with the clockwise spin. So here that electron is located. So to know an electron's location exactly, we have to know these 4 quantum numbers. First, we have to know principal quantum number value. So by that we can understand in which that electron is located, in which orbit that electron is located. And if you know L value, in which subshell it is located, we can identify. And by using M value, we can say in which orbital that electron is located in the subshell. And again, by knowing the S value, we can know the spin of the electron in that particular orbital, either in the clockwise spin or anti-clockwise spin. So in this way, we can give exact location of an electron in an atom by using this set of 4 quantum numbers. Okay. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for receiving latest updates and recorded videos. Thank you.